So now I want to talk about the not introduction rule. So the way it works is that if we from some assumption x get to a contradiction, that means we assume x, but then we see that it leads to a contradiction, then we can conclude not x. Sorry. In the setup of a box proof, what it means is that you suppose you want to justify a not. We want to justify not x. The way we justify it is we say, okay, we want to show that not x. So let's assume x. We do a box on top. It's a sort of automatic thing when you have a not x you want to justify. You do a box on top. We start off assuming x, and then we show that somehow leads to a contradiction. That's a not introduction. Now, I also want to talk about the not elimination. Let me see. So the not elimination rule, it works basically if we can argue x, but we can somehow also argue not x. From these two, we get a contradiction. Now, you might, of course, ask, how is it possible to argue x and also argue not x? Well, keep in mind that it could be we are doing that inside a box. That means inside a hypothetical situation, and that is perfectly all right. You know, I would get worried if I got a contradiction outside all the boxes, because that would be like a contradiction in the real world. That is certainly not something we would like. But inside a box, it often happens we get contradictions. So let me give an example to illustrate that. So let's say we want to suppose we want to argue that A implies the double negation. A implies not A. Now, obviously, we know this from logic that is clearly something that is true. Certainly, with truth table, it's true that the double negation of something is true. But let's just think about it now as a formal deviation in logic. So the first step would be we have an implication here, so we will start off assuming A, and then we want to somehow derive not A. Now at this stage, we can see that we somehow the target for our argument is something that begins with a not. And that suggests that very strongly, actually, that it's almost, we can say, without loss of generality, we can assume that we got that not somehow by an argument where we started off by assuming the thing without the not. In this case, it becomes not A, but you see, this is the target, but we have removed the not. And then from that, we get a contradiction. So this is like a way you could justify that not A simply by assuming not A and showing that give a contradiction. And now you can actually see how we get a contradiction, because we have assumed A in this box, but inside that box we also assume not A. So we're actually in a situation, inside this box we're in a situation that is contradictory, because we both have A and not A, and that allows us to deduce this. So you see, this is an example where we both have the not introduction here. We have, this one, by the way, was of course an implication introduction. That's a different issue. And here, this line we can justify by a not elimination. We could also say that it's like a kind of contradiction rule we have, that if we have A and we have not A, contradiction rule. But in natural deduction, this rule is typically referred to as a not elimination. And it often appears together, so it's rare you would find a not elimination without a not introduction and vice versa. They kind of go together, because the not introduction, for sure, the way you introduce it, if you recall, was that we started off with, want to prove not x, and the way we do it is that we assume x and we get a contradiction. But to get the contradiction, we need a a not elimination basically. It's the only way really we can get to a contradiction. So you can see that a not introduction and a not elimination kind of go together. Now I want to do another example. Let me see. Let's do, for example, not A implies, let's say, not A. So again, the first step, because if we have an implication, first step is to assume not A here, so I want to get to not A. So that was the first automatic step. The next step is actually also automatic, because we have like a not here in front. So really, in order to justify this thing here, we simply reduce it to the problem of getting from not A to a contradiction. But then we are done, because again you see we can justify each step. The beginning of a box, of course, is just an assumption. But this line 3 is a direct contradiction of these two lines. So this is like a not elimination from line 1 and line 2. Let me put line numbers here just to get the annotation right. While this one is a that was a not elimination, and as I said, often not elimination and not introduction goes together. They sort of appears together. So you can see we have an elimination here, and here we have an introduction, because we start off from something, get a contradiction, and then we get the thing with negation in front. So that's a not introduction happening in the box, starting in line 2, finishing in line 3. The last thing is a usual implication intro from line, in this case line 2.